Stasio, and I'm going to demonstrate my Python project. For this class, I built a weather application that essentially returns the current conditions and forecasted weather in a city that the user selects. The user can select that city via city name or by zip code. So I'll go ahead and start by putting in a city name here, Buffalo. I'll click go. And once I click go, a couple of things happen. Essentially what happens is a couple of API calls are made. One API call is for the current conditions, and another API is called to return forecasted data. That actually happens simultaneously via the use of threading. So to help build efficiencies in the application, those calls are made, again, simultaneously. So what I can do is I can view Buffalo by the current conditions, and you can see it just returns some various weather data. And I can also see the forecasted data in 3-hour increments. So you can see at 7 p.m. What it's forecasted to be, and then, as I mentioned, every 3 hours after that. Essentially what this is, on the left-hand column, this is a stack, and in the right column here is a queue. And when I advance, what it does is it pops from the queue and pushes onto the stack. And same is true when I decrement. It'll pop from the stack and insert into the queue. And you can see when I go back to the beginning, then my back button is disabled in order to prevent me from having an out of bounds index. And the same would be true if I were to advance all the way to the end of the queue. My next button would be disabled as well. Okay. So as I mentioned, you can also search by zip code. So if I go ahead and pop a zip code in here, go, and see I've selected Boston, and obviously the same is true. Same feature set. There's also some error checking built into the application. So if I were to attempt to put a city name in that contained digits or numeric, for example, I'll get a custom error message that'll tell me exactly why my input was rejected. My city name can't contain numbers. And also, same is true for zip code. If I tried to put a zip code in that was too short, it's going to tell me that the zip code needs to be exactly 5 digits. Same is true if I try to, let's say, put a zip code with numbers and letters. Click go. It's going to tell me the zip code can only contain numbers. Okay, so what I'd like to do is just search a few more cities so I can demonstrate some of the other features. I don't even really need to click into the data, but what I'd like to do is just search some cities that are in different time zones. So it's Vegas. Let's do Toronto. Okay. So this button here is called Location Zone, and what I can do with this is it actually returns a dictionary structure, a key-value pair, and what it does is it organizes the values by their time zone. So essentially the time zone is the key, and the locations that I've searched are those values. So you can see America, New York, I searched for Buffalo, Boston, Vegas, Chicago, obviously. Okay. One of the other things I can do is utilize this weather tree, and this is a tree data structure that recursively searches the locations I've searched based on their current temperature. So when I launch this, you can see that the temperature tree is the top node in the data structure, and then it will recursively search cold weather, which I didn't search any cold weather cities. Right now it's nice in Boston and Toronto. It's hot in Buffalo, Chicago, Vegas. And as I mentioned, it's recursively searching, so it'll do it twice. But let me actually see if I can find a cold weather city, Sydney. It's wintertime right now in Australia, right? So it's like, 61, so that should be considered cold. And then if I, again, put it on a weather tree, you can see cold weather, and there you go, there's Sydney. And just advance this here. Okay. Something else you can do is called map it. So this right here, this button, let me bring in my browser. What this does is if I click this, you can see it opens up a browser, and what it does is then it returns the current temperature and conditions, but also calls another API, Google Map API, and actually plots that location on a map. Okay. So let me see if I can clear this. Let's search another city here just to demonstrate that again. Zip code 5, go. So here's Somerville, and let me again click map it, and you can see it returns the weather data of Somerville in right outside of Charleston, South Carolina. And then the last feature I would like to show or demonstrate is this button called Who Am I? This isn't really relevant as far as the weather application or weather data, but I thought it was pretty neat what you can do with some of the Python libraries. You can actually look up information about the person using your application. So when the application is first launched, I'm capturing specific information about the end user and storing that information in the database, and then when the user clicks this Who Am I button, it retrieves that info from the database and again uses the browser feature to display some of that information. So you can see I can get the name of the PC, the system, the platform the user's on. I can also get their public IP address, and with that information I can look up their location, and then I can actually plot that location on a map. So that pretty much concludes all the features in my application. Thank you for watching.